Hi everybody, Justin here from A is our first video on section 5. Section 5 is entitled Gases. So we're going to start off by giving some background on gases and pressure and units of pressure. We're then going to go into individual gas laws, then the combined gas law, the ideal gas law, and we'll go from there. Okay? So first things first, let's just get started on page 1 of section 5, gases. The first bullet point on page 1 of our notes today says, although relatively few substances exist as gases under typical conditions, they're very important. One very obvious example is our atmosphere, right? Our atmosphere supports life. It's a waste receptacle for exhaust gases produced here on Earth. And also the atmosphere shields us from the sun and its harmful radiation. So all gases exert pressure, and we'll define pressure in just a second. Pressure in terms of gases. All gases exert pressure on their surroundings. Now the definition of pressure as it relates to gases in chemistry is the force exerted by gas molecules as they strike the surfaces around them. So if they're in a container, a sealed container, then the gas pressure is the molecules striking the insides of that container. Third bullet point I want to mention here is the gases most familiar to us are the ones that make up our atmosphere. And in parentheses here, I've got some of the gases that make up our atmosphere. Nitrogen, oxygen, argon, carbon dioxide, neon, helium, CH4 is methane. Now all of the gases that comprise our atmosphere, together they exert what's known as atmospheric pressure on us and on the Earth. Together, they exert atmospheric pressure on us and on the Earth. All right? Now, page 2 of today's notes, we want to talk about how pressure is measured. A device used to measure atmospheric pressure is called a barometer. So, a barometer is a device used to measure atmospheric pressure. The barometer, by the way, was invented by an Italian physicist named Torricelli. The first 4 letters of his name are TORR. That's one of the units that we use in units of pressure. But anyway, back to the barometer. So what I'm drawing here is a little pool of mercury down below. Now I've made a wider kind of pool so you can see it there for emphasis. But the atmospheric pressure is pushing down on that pool of mercury. And the atmospheric pressure pushes down, it pushes mercury up that tube a distance of 760 millimeters. So the mercury moves up that tube, which is submerged, open on the bottom, and submerged in the pool of mercury. And the atmospheric pressure under standard conditions, we'll get to that in a second, atmospheric pressure pushes down on the pool, pushes the mercury up to a barometer reading of 760 millimeters. Okay, so at sea level, the atmosphere pushes the mercury 760 millimeters up the tube. Okay, now we call that standard pressure. Standard pressure is 760 millimeters mercury. All right, now that little mmHg is one particular unit for pressure, right? Units of distance, for example, inches, meters, kilometers, furlongs, centimeters. You get the idea. We have different units for pressure as well. We'll get to that in just a bit. Now, pressure. What affects pressure? Well, there are lots of things affect the pressure. But 2 factors that can change atmospheric pressure, the 2 factors I want to mention, the first one is altitude. At higher elevations, right? When you're up in the mountains, there's a smaller column or a smaller amount of air above you. You're higher up, so the amount of air above you is less. So the atmospheric pressure would be less. Let me say that again. At higher elevations, there is a smaller column or amount of air above you. So the atmospheric pressure would be less. A barometer reading would be less than 760 millimeters mercury. Okay? Now the opposite is also true. Okay? So if you are in lower elevations, like in a valley or in the Grand Canyon here in the US, the opposite is also true. So these lower elevations would mean you have a lot more air or a larger column of air above you, right? That's heavier. Because it's heavier, the atmospheric pressure is greater. Okay, second factor affecting pressure or atmospheric pressure is the weather, humidity. How many water molecules are in the atmosphere? The more molecules you have in the atmosphere, the more amount of molecules in the atmosphere, the greater the atmospheric pressure. So in the tropics, there's more water molecules in the air, right? It's very humid in the tropics. Around the equator, there's more water molecules in the air, so the atmosphere weighs more and the atmospheric pressure is greater. Well, the opposite's true in dry regions and in deserts around the world. Humidity is very low. Air is very dry. There's not that many water molecules. Relatively few water molecules in the air or in the atmosphere leads to a lower atmospheric pressure. Okay? So the very last thing I want to talk about today in this video, in video number 1 here for section 5 gases, are units of pressure. Now, here are all the main units of pressure. They're all equal to each other as I've drawn them out right here. 760 millimeters mercury is the same pressure as 1 atm or 1 atmosphere, is the same pressure as 760 torr, is the same pressure as 101,325 pascals. Gets a little unit PA there. And that's also equal to 14.7 psi, where psi is pounds per square inch. Now, any two of these 5 can be used as conversion factors, and we're going to see that in our example right here. The example says, represent a pressure of 49 torr in atmospheres, in millimeters mercury, and in pascals. So start with what you're given, put it over 1, right? Like we learned in dimensional analysis in sections 2 and 3. So for every 760 torr, there's 1 atm. 2 sig figs, my answer is 0.064 atm. Now let's convert it to millimeters mercury. 49 torr, start with what you're given, put it over 1. Well, for every 760 torr, there's 760 millimeters mercury. Let's just rewrite my answer, 49 millimeters Hg. The last one, converting 49 torr into pascals. Well, for every 760 torr, that cancels my torrs, puts me into pascals, 6,500 pascals. Okay, so I started with 2 sig in each of those cases, and my answer was in 2 sig figs. All right, just a note here. All of those pressure values that we just got in that last sample problem, whether the units were millimeters mercury or atm or torr, that was the same value, the same pressure, just put into different units, right? Like 12 inches is equal to a foot, or 100 centimeters is equal to 1 meter. That's all conversion factors do. Conversion factors change your units, not your value. All right, now in our next video, video number 2 for section 5, we're going to talk about 3 individual gas laws. We're going to talk about something called Boyle's law, which shows the relationship between pressure, gas pressure, and gas volume. We're going to talk about Charles' law, which talks about gas volume and gas temperature. And then we're going to talk about Avogadro's law, which talks about volume and the amount of a substance and the relationship between the two. So volume and moles relationship.